Okay, so hello guys. Welcome to another problem solving session with Special Maths Academy. So my name is Obukomere Jaife. Yeah, I've been here for a while now, so I think you guys already know my name. Today we're looking at problem one of the 2022-2023 Nigerian Mathematics Olympiad second round. The first problem, and it says to find given that PQR are distinct roots of x cubed minus x squared plus x minus 2 equals 0. Find the value of p cube plus q cube plus r cube. Wow. So this is our problem, the first problem in the exam. So I feel this problem was actually kind of routine. I think with our normal strategies it should be doable. So first of all, I think the first thing we want to know is to know what roots are. So we can say let this uh p of x be like this x cube minus x squared plus x minus 2. So if p is a root, of p of x, it means that p of p equals 0. Yeah, I know it's like kind of confusing. Okay, let's use something else. Okay, but that's just what it means. So it means that when x equals p, that means p cubed minus p squared plus p minus 2 equals 0. That is just what this implies, that p is a root. So this is just what p is like. So this polynomial is like of degree 3. This means the highest power of x is 3, so it has 3 roots, p, q, r. So they said we should find the value of p cube plus q cube plus r cube. So one way of doing this would be to try solving this equation, but this would be really difficult to accomplish because solving, if it were quadratic we could have tried that, but with degree 3 I would advise we don't do that. So we'll go another way, like something that will still always work, because solving that polynomial will not always work, but this will always work, what I intend to do now. So I'm going to use like a knowledge like we did, I will have from high school, like normal school math, only quadratics. So that assuming they give you like a polynomial, like a quadratic equation, they said x squared minus 3x plus 2 equals to 0. They say x equals to 2 and x equals to, okay, let's say assuming x equals to a and x equals to b are roots of this, then we'll have something like x minus a equals 0. Okay, assuming this, okay, let's do something different. Like assuming they give you, let me explain it. Assuming they tell you that, okay, assuming they tell you that um x equals to 2 and x equals to 1 are roots of a quadratic equation, an unknown quadratic, right? Then they will now say find the equation, right? So this is like a common problem. I think it should be SS2 general maths. So generally what you do is that you have something like if x equals to 2 or x equals to 1, you have that either x minus 2 equals 0 or x minus 1 equals 0, right? Then to get the equation, that means when you multiply this, you get x minus 2, x minus 1 equals 0, right? Then you expand, so you have something like x squared minus 2x minus x plus 2 equals 0. So you have the equation as x squared minus 3x. So how did you move? You move from here to here, like from roots to equation, right? Yeah, so this was kind of like straightforward. So I'm going to use that same knowledge here. It works somehow similarly here for polynomials too. So what this time is not going to be 3. So I'm going to clean this now. So let me explain what I mean. So they said x equals to PQR are roots of this equation, right? PQR are roots of this. So it means the roots are, that means x equals to P, x equals to Q, and x equals to R are roots, right, of this. So it means this, I can write this as x minus p equals to 0. This as x minus q equals to 0. And this as x minus arrow equals to 0, right? These are the three. So when I multiply these three together, I have that x minus p, x minus q, and x minus arrow is equals to 0. But the product of these three should actually give me, so these are like factors of this. So you know that when we multiply this, when we did one for quadratic, when we multiply these two, we got the original equations back, right? So if I multiply these three now, I should also get this equation, this x cubed minus x squared minus plus x minus equals to 0. So it means that this x minus p times x minus q times x minus arrow has to be equals to x cubed minus x squared plus x minus 2. So this is what this means, since PQR are roots of this. So if I expand this left hand side now, so if I expand this, I'll have that x cubed minus p into, okay, sorry, minus, if you expand, just expand this. I'm not going to spend too much time expanding that. Expansion isn't too difficult. Minus x squared. Okay, let's see. Okay, yeah. Minus x squared into p plus. Expansion is not too difficult. So just expand. If you expand, you should have this. Then plus x into pq plus p arrow plus q arrow minus pq arrow is equals to this, right? When you expand, so then you can like compare terms. So the x cube on this side has to be like equal to the x cube on this side, so that's fine. So on this side we see that this x squared minus x squared, okay, pq into p plus q plus r has to be equal to minus x squared on this side. So it means that um minus x squared into p plus q plus arrow is equals to minus x squared, right? And then we have that when I divide both sides by x squared minus x squared, I have p plus q plus r equals to 1. So I can like call this equation 1, right? Then the same thing here, this plus x into this has to be equals to plus x on this side. What does that mean? That x into pq plus q arrow plus p arrow has to be equals to plus x on this side, okay? And this means that pq plus q arrow plus p arrow equals to 1 when you divide both sides by plus x. Then the last term is minus pq arrow. So you can see it's minus pq arrow and minus 2. So it means minus pq arrow is equals to minus 2. Then this means pq arrow is equals to 2. Okay, so we know what p plus q plus arrow, pq plus q arrow plus p arrow is, and what pq arrow equals to. But we want to find it. So this is our aim. This is our aim. Like aim. This is what the problem wants us to find. So you can use this factorization. You now like recall. So there's a common factorization that this, that p cube plus q cube plus arrow cube minus 3pq arrow is equals to this. Right? So if you look at this, we have this, like this p plus q plus arrow, we have this. This is like 1. This is our equation 1. We also have this this pq. I can rewrite this as, okay, let me rewrite this, and this is equals to, right? So I've brought out the minus sign. That is why that side is having plus now. So this is like our equation 2 we got. This is our equation 1. And on this side we have this as, we also have this. This is like our 3. So we have 1, 2, 3, but there's something still missing that we do not have yet. We don't have what p square plus q square plus r square is. We don't have this. So how do we find this? It's still like a matter of just factorizations. You can, so you still have to recall again for the second time. So you have to recall again that this, if you've played around with expansions a lot, you will notice this is true. Right? So we have this, we know this, and we can easily find this by solving. So I just substitute. So therefore, so this implies that p plus q plus r is 1. So this implies that 1 square is p squared plus q squared plus r squared plus 2 into pq plus qr plus pr is 1. And this implies that 1 is p squared plus q squared plus r squared plus 2. And then I have that p squared plus q squared plus r squared equals 1 minus 2, which is minus 1. So p squared plus q squared plus r squared is minus 1. So wow. So the sum of 3 squares is equals to a negative number, minus 1. Why? Also, this is already bad. Why? Because if we had tried solving for p, q, and r before, we would have had serious issues. Because if 3 squares are equal to a negative number, then that means the numbers are complex, and I don't think we have the tools, or you want to be looking for the tools to solve a complex polynomial inside the example. So this is why solving such kind of polynomials will not end well. You might not succeed. You can, but is it really worth the risk when you can just like play around with this? So I know this is minus 1. So I can come back now to this, to the one in blue, and just plug in values. So this is why generally I advise people, if you can avoid solving the equation, the polynomial. Sometimes solving is cool too, but generally when they give you sums, you don't want to like solve. Instead, you want to just try and manipulate the coefficients to get something useful. So I can just plug in here. So you remember that this PQ arrow is so we know that PQ arrow is 2, so this is minus. So I'm using this. So let me just like show you where this is coming from. Minus 3 times 2, p plus q plus r, we got it as 1. We got p squared plus q squared plus r squared as minus 1. So I'm just substituting. Then minus this. I think we also got this as 1. So this is minus 1 minus 1. So we know that pq plus rq plus qq plus rq minus 6 is 1 times minus 2. And then this means that pq plus qq plus rq minus 6 equals to minus 2. And then we have that p cube plus q cube plus r cube equals 6 minus 2, which is 4. Right? So we have the answer as 4. So our final answer is actually 4. Wow. And if you see, we do not have to solve for p, q, and r, we just have to manipulate it. So that brings us to the end of this problem, like the first problem from that exam. So stick around this channel. We'll be adding the solutions, the other solutions to this channel. Then to all our dedicated viewers, thank you so much for your subscription. We hit 1,000 followers recently, and we couldn't have done that without you. So still keep telling people about SMA. Stick around. SMA is always there. My name is Obukome Jaife, and with that, we've come to the end of this problem solving session. Goodbye. See you again soon.